Hello everyone, welcome back. Today, we're going to delve into the process of setting up a Squidnet Render farm network configuration. This involves establishing a centralized network attached storage NAS, which serves as the primary storage and access point for all rendering content. The central NAS on the render farm acts as the repository for all rendering content. This is where the master uploads content to and from user environments. It's also the location from which the render nodes pull content, into which they write content back. Essentially, all the rendering information involved within the render farm, or the rendering data, is stored on this central NAS. In this tutorial, we'll be setting up a Linux-based central NAS server. Our render farm will consist of a combination of Windows, Linux, and macOS rendering nodes. We'll configure the render nodes paths to point to the network storage device, which in this case is a Linux-based NAS. As you can see on the screen, we'll be setting up paths on each particular platform. We'll have 4 different node types: the NAS server, the Windows render node, the Linux-based render nodes, and the macOS render node. Once we've completed the setup, we'll verify that each render node has read and write permissions to the central NAS. This ensures that all nodes can access and modify the rendering content as needed. The next screen provides a graphical layout of our setup. We'll set up the central NAS in the middle, which will act as the repository for all rendering content. Across the network, we'll have 3 different types of rendering nodes: Windows, Linux, and macOS. Each one will map their local environment to the network storage device. We'll discuss this in more detail as we proceed with the tutorial. Let's continue with the video now. Okay, we're back in the Squidnet main user interface. As you can see, we have our 6 render farm nodes here, including the master controller and 5 render nodes. Let's start by bringing up the column that shows the operating system type for each node. You can do this by navigating to the Operating System option and selecting it. This reveals that we have a mix of Windows and Linux nodes. Specifically, we have a Windows 64 computers, an Ubuntu 18.04 server, and a macOS 14.4.1 MacBook. Our master node controller is here, along with our slave nodes. The first step in our process is to define where the central content will be stored within the system and how it will be accessed by all render farm nodes. To do this, navigate to the Cloud Rendering interface. Once there, press the Render Farm button. At the top, you'll see the storage locations for all 3 types of operating systems: Windows, Linux, and macOS. Your task is to cut and paste the path to our central NAS, a Linux-based storage device, as seen by each operating system. As you can see, each operating system perceives the network device differently. It's crucial to ensure that each operating system is set up appropriately with the correct read and write permissions to the central NAS. For instance, on macOS, you'll likely need to tell the OS that it's okay for the Squidnet daemon to have access to the central NAS. By default, this permission setting is disabled. On Windows, ensure that your antivirus software is configured to allow read and write access to the central storage repository. Once you've set this up, save your settings and apply them. The next step is to run a tool called FarmCheck. You can find this in the Help menu. FarmCheck runs read and write operations to the nodes. Essentially, the master sends messages to the nodes, asking them to write content and read content back from their respective reference paths to the network storage device. As you can see, each operating system writes to its respective folders. However, all these points lead to the same physical location on the NAS. Therefore, from the perspective of each operating system, you'll see the content from each OS the same. To run the test, right-click on all the machines and select Start. The test will run for a few seconds, writing content to these physical folders. Once it's done, it will give you a pass or fail indication. In this case, all the tests passed, meaning that the master node sent a message to each of the render nodes, and they wrote test data to their respective paths as shown. If you get a pass indication for all these tests, then you're good to go. At this point, we've covered the basics for this test. There are a few other options to explore, but for the purpose of this video, we focused on ensuring that our path configuration settings are correct. That's it for now. We'll see you in the next video.